Another rule that we're adding to our proof system is the existential introduction rule, which gives you a way to derive existentially quantified whiffs, like there is an xtx. And what this rule says about when you're allowed to derive an existentially quantified whiff is really simple. It says that an existentially quantified whiff can be derived from any instance of it. In other words, it says that if there's a specific individual from the domain that you know meets a certain condition, then you can conclude that there's at least one individual from the domain that meets that condition. For example, if you know that James is a toddler, you know TJ, then you can conclude that there's at least someone that's a toddler. There is an xtx. Or if you know that Magnolia is friends with everyone, you know for all x, f mx, then you can conclude that there's at least someone that's friends with everyone. There is a y such that for all x, f, y, x. The only potentially tricky thing to be aware of with this rule is that the same whiff can be an instance of many different existentially quantified whiffs. In that case, the existential introduction rule allows you to derive each of those different existentially quantified formulas. For example, suppose you have LAA available in your proof, Alex loves himself. That's an instance of there is an x, LXX, someone loves themselves, so you can derive that from LAA using existential introduction. Likewise, LAA is also an instance of there is an x, LXA, someone loves Alex, so you can derive that too. And LAA is also an instance of there is an x, LAX, Alex loves someone. So you can derive that as well. That should all make perfect sense since all of those things do follow from the claim that Alex loves Alex.